Hello everybody and welcome back to Unit 8 of Regents Chemistry, where we are talking about reactions and stoichiometry. Today we will look at how to balance chemical equations. Now, whenever we are balancing a chemical equation, the mass, energy, and charge, all three of those things are conserved. What that means is that if you guys look at this chemical reaction at the bottom, we have the reactants on the left hand side. Reactants are what we start with, and then we have the products on the right hand side. Products are what we get as a result of a chemical reaction. So in this case, we are starting with hydrogen and oxygen gases, and then as a product, we are getting water. So what we mean by the conservation of mass, energy, and charge is that the mass stays the same on both sides. The energy stays the same on both sides. And the charge, the positive and negative charges, they stay the same on both sides of the equation. So when you guys are balancing your equations, you will be expected to look at the number of atoms of each element on both sides. So for example, in this equation that we have on the slide right now, hydrogen, we have 2 times 2 because the first 2 is the coefficient and the second 2 is the subscript. So whenever we have to count how many hydrogens do we have, we multiply the coefficient and the subscript. So in the right now on the reactant side, we have 4 hydrogens because 2 times 2 gives us 4. And we have 1 times 2, 2 oxygens on the reactant side. Now let's count these elements on the product side. So on the product side right now, we have 2 times 2, 4 hydrogens again. And then we have 2 times 1, only 2 oxygens right now. So basically, we have 4 hydrogens on both sides and we have 2 oxygens on both sides. Those numbers are the same. That means our equation is balanced. When those numbers are not the same, that's when you need to go ahead and make them equal so that your equation is balanced. So let's practice that. Now here we have an equation which is unbalanced right now, or let's say you just don't know if it's balanced or not. We are about to figure out if it is. If it's not, we'll have to balance it. So look at your reactant side and start with the reactant that has the greatest subscript. So in this case, right now, we have phosphorus on the reactant side with a subscript of 4. And we have oxygen with a subscript of 2. So 4 is definitely greater than 2. So let's start with phosphorus. Because there's no coefficient, there's only a subscript of 4. So that tells us that right now we have 4 phosphorus on the reactant side. On the product side, however, once again, there's no coefficient, so that's one less thing to worry about. So we'll just look at the subscript for phosphorus, and we only have 2 phosphorus on the product side right now. So it's not balanced. We want that number to be the same. So if we have 4 phosphorus on the reactant side, we want to have 4 phosphorus on the product side too. So what we can do is that we can add a coefficient. So you'll have to see what number do I multiply with 2 to make it a 4. So 2 times 2 is going to be 4. So what we can do is that we can add a coefficient of 2 with the phosphorus. So right now, phosphorus has a coefficient of 2 and it has a subscript of 2. So 2 times 2 will have 4 phosphorus on the product side. So now that the phosphorus is balanced, we can move on to the next element. So let's look at oxygen. We have only 2 oxygens right now on the reactant side. On the product side, however, always, 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 do not ever forget that. Always remember to multiply your coefficients with the subscript. So on the product side right now, the coefficient is 2 for oxygen and for phosphorus, for both of them. So we'll multiply that 2 with the subscript of 5 for oxygen. So 2 times 5, we have 10 oxygens. All right, now once again, oxygen is not balanced. We want to make, if we have 10 oxygens in the products, we want to have 10 oxygens in the reactants as well. So what can we do to make that 2 a 10? We can multiply that with a 5. So how do we add that 5? We make it a coefficient with the oxygen. All right, so there you go. All you did was match the numbers, and if they were not the same, you just added the coefficients so that they can multiply and we can have equal number of each element on both sides. And there you now have a balanced chemical equation. Let's look at another example. So once again, in this case, we'll start by looking at the reactant side, and we'll look for the element that has the largest or the greatest subscript. So in this case, carbon has a subscript of 3, hydrogen has a subscript of 8, oxygen has a subscript of 2. So hydrogen has the largest, we'll start with that. So on the reactant side, right now there's no coefficient, we only have the subscript for hydrogen, so that makes our work easier. We only have 8 hydrogens. On the product side, however, we only have 2 hydrogens because once again, no coefficient present, just the subscript, so that gives us the number of 2 hydrogens. Now we want to make both of them equal. So how do we make the 2 and 8? By multiplying that with a 4. So we'll go ahead and add a coefficient of 4 with the H2O. All right, so now the hydrogen is balanced. We'll move on to the next one. What's the next largest subscript after hydrogen? That would be carbon. So right now we have 3 carbons on the reactant side. On the product side, this carbon doesn't have any coefficient, it doesn't have any subscript. So everything is just 1, which means we only have 1 carbon right now. So how can we make that 1 a 3? By multiplying that with a 3. So we'll go ahead and add a coefficient of 3 with CO2. Now the last step would be to balance the last element, which would be oxygen. Now on the reactant side, it's pretty easy. We only have 1 compound or molecule that has oxygen in it. There's no coefficient, only a subscript of 2, so that tells us we have 2 oxygens on the reactant side. On the product side, however, we have oxygen in CO2, and we also have oxygen in H2O. Whenever that happens, you want to make sure that you are counting the total number of oxygens. You cannot just count the number of oxygens in CO2 and ignore the H2O. We gotta count all of them. So let's look at CO2 first. The coefficient is 3 and the subscript with oxygen is 2. So 3 times 2, we have 6 oxygens here. Plus, now we gotta plus the oxygens in H2O. The coefficient is 4. The subscript is just 1. So 4 times 1, we have 4 oxygens there. So now 6 plus 4, in total, on the product side, we have 10 oxygens. So now, when we have to balance them, how do we make the 2 a 10? By multiplying the 2 with a 5. So we will just go ahead and add a coefficient of 5 with the O2. So now the carbon is balanced, hydrogen is balanced, and oxygen is balanced. And there we have a balanced chemical equation. And that's it for now, guys. Take care. I'll see you in the next one.